Okay, so here we are in practice exam number 3, part 2. We're doing question 11. A steamboat travels 9 kilometers faster than a freighter. A steamboat travels 118 kilometers in the same time. The freighter travels 100. So let's set up a relationship here. It's D equals R times T, right? Distance equals rate times time. The dirt equation. All right, and so we have a steamboat. So this is the steamboat, and this is the freighter. So top row is going to be the steamboat. Bottom row is going to be the freighter. It says the steamboat travels 9 kilometers faster. What do we do with faster? Faster is like saying more. 9 more. So the steamboat is x plus 9. Now, is that his distance, his rate, or his time? Well, kilometers per hour, that's like miles per hour. That's your speed. Your speed is your rate. So the steamboat's rate is x plus 9, and that means the freighter's just x, because the steamboat is 9 faster. That's what we always do in a word problem. Whenever they say something is 9 more, it's x plus 9, and the other box is just x. If they say something is 9 slower or 9 less, that would be x minus 9, and the other box would just be x. The steamboat travels 118 kilometers. That's a distance, right, for the steamboat. In the same time, the freighter travels 100 kilometers. That's the distance for the freighter. Okay, now, how do we remember how this works? So first, you get, I don't have room there. Let me come over here. Step 1 is we get 4 boxes from the words. Step 2 is you get the last 2 boxes from, remember what it is? You start with the D equals R times T, the equation, the dirt equation, and you're trying to find T, right? These 2 boxes are T boxes. How do you solve for T? Divide by R. T is D over R. So the D box over the R box, this will be 118 over x plus 9. This is D over R, 100 over x. And then lastly, step 3, remove last 2 boxes. Write some kind of equation. So what kind of equation can I write? 118 over x plus 9 and 100 over x must be equal. This box must equal that box. Why do I know those 2 boxes are equal? Those are time boxes, right? They're both underneath T, and it says same time. Those 2 times, the time for the steamboat and the time for the freighter, these 2 time boxes for the steamboat and freighter must be equal. They must be same. So there's my equation. Let me go to a fresh screen and solve it. So 118 over x plus 9 equals 118 over x plus 9 equals 100 over x. Okay, now how do we solve this thing? Diagonal, diagonal. 118x is 100 times x plus 9. Distribute. 100x plus 900. Whoops, a little scribbly there. Okay, now we want to get x alone. So what do you do when you have x on opposite sides? You subtract the lower one. This is gone. So we get 18x is 900. Bring that down. Last step is divide by 18. So x is 50, right? X is 50. Now, what's the answer to the question? They want to know, find the speed of each boat. How do we find the speed of each boat? Where's the speed? Which box? Remember, this X now is the key, but I still have to go unlock the doors. That key will unlock any door. Let's go back and look at the doors, make sure we unlock the right doors. They want speed of each boat. Speed is rate. They want this one and this one. So put in the 50, right? We now know x is 50. So put in a 50 here and a 50 there. So 50 plus 9, or 59, is the speed of the steamboat. And just plain 50 is the freighter. So the steamboat is 59. Freighter is 50, was that right? Yeah. So there we go. All right, let's move forward with number 12. I'm going to rewrite number 12 right up here. So R equals, what is that? FT over F plus T. Okay, and I'm supposed to solve for T. Okay, so put this over 1, diagonal, diagonal. So R times F plus, I'm going to make that T capital. Well, I better not. Keep it like that. Equals 1 times FT. Okay, so distribute this R. RF plus RT. 1 times FT is just FT. Okay, so here's the wall. Trying to, what are we trying to solve for now? What do we want to get alone? T. I want to get T alone. Where's T? T's here and T's there. Notice both those two have a T in them, huh? So what do you do when T is in two places like that? So when it's in two places, whoops, kind of getting scribbly over there. So when it's in two places, get them on the same side. Step 2. Factor out T and then divide. So get them on the same side. So move this over so both the T terms will be on the same side. So this will be FT. Remember when the RT moves over, it becomes negative RT. Right? This positive RT jumped to the other side, became negative RT. And then next step, factor out T, so take out a T, parenthesis, F minus R. And last step then, divide. Divide by what? By the whole F minus R, because that'll cancel, and the little t's alone. We solve for T, there it is. And make sure you type that in, it's case sensitive, so capital R, little f, capital R. There's the answer, we got little t alone. Okay, so number 13 now. Bring it up here. So 1 over R plus 1 over S equals 1. And we're supposed to solve for R. Okay, so how do we solve for the little r? Well, this back on number 12 only had one fraction on the left side, so I could just put it over 1 fraction on the right side, and just cross multiply. But question 13 has 1, 2, 3 different terms, doesn't it? So I can't just cross multiply. Well, then what do? I multiply through top by the LCD, the common denominator. What is the common denominator? R times S, right? You just multiply the denominators together and you go RS, 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 top, straight on through. Okay, then cancel whatever you can. R cancels R, bring down S, plus S cancels S, bring down R. And this side is RS. Okay, now we're solving for what? For R. Where's R? Here and here. Two places again. Remember how we do this? We just jump this one to the other side. You get the two R terms. Here's the wall. Get the two R terms on the same side. RS minus R, right? Because this plus R, when it jumps to the other side, becomes a minus R. So get the two R terms. Say this has R and this has R. We're trying to solve for R. Get the two R terms on the same side. And then factor out R. What does that leave? S, just S, minus 1, huh? Because RS and R times 1 would go back to RS, and R times 1 would just be R. Okay, and now last step to get r alone. Divide by s minus 1, divide by s minus 1. There it is. R's alone. We solved for r. Okay, number 14. So 9 to the 5 has power. We can do this right on your calculator. You just go 9 to the power. You might have an up arrow button. Some calculators have a y to the x button. And then you got to put parentheses, 5 divided by 2. You got to put the power in parentheses on your calculator. So 9 to the 5 has power. And then just hit equals at the end here. Oops. Just hit the equals button, and you should get the answer on your calculator. It's going to be something big. What is it? I believe it's 729 will be the answer your calculator will tell you. No, my mistake. 243. There we go. 243. That's what the calculator will tell you. All right, let's keep moving. Number 15. All right, laws of exponents. We have 4.2 and 4.2. Same base, different powers. What's the rule when you have same base, top and bottom with different powers? Well, let's think about it. The rule is this. What if you have 2 to the third over 2 to the fifth? Well, you subtract them. The 5 is bigger than the 3, so that leaves 1 over 2 squared. Remember how that works? You subtract these bases, and wherever the bigger one is, the bigger one's on the bottom in this case, the answer ends up in the bottom, and you just have a 1 on the top. So that's what we have to do here. This is going to be, so the first thing, we're going to need to subtract these bases. These powers, because the bases are the same, subtract the powers. But to subtract those powers, I've got to make them common denominator. So I got to multiply top and bottom of this one by 7, top and bottom of that one by 4. Do you see why I'm doing that? Let me show you if that, maybe this next step will make more sense. So what's that going to become? That's 5 times 7, 35, 4 times 7, 28. That's the power here. 4 times 6, 24, over 4 times 7, 28. So I made both the powers have the same denominator. See what I did? I got common denominator in those powers. Now I can subtract the powers. Now where's the bigger power, top or bottom? The bigger one is on the top. This is bigger than this, huh? So the answer ends up wherever the bigger power is. I showed you an example down here where the bigger power, the 5, was bigger than the 3, the bottom. So the answer ended up in the bottom. But this one, the answer is ended up in the top. It's going to be 35 minus 24. What is that? 11/28. And there we go. You don't need to put a 1 on the bottom because we never leave 1s on the bottom. Dividing by 1 doesn't do anything. So we never show 1s on the bottom. So there's our answer, 4.2. to the power 11 over 28. Let's try number 16. I'm going to rewrite number 16 on a fresh screen. This one right here. Root of 1350 x to the 4th. Is that right? Yeah. They want me to simplify. So to simplify that, you're going to have to break it down with your calculator. Whenever we have something ending with a 0, I know that means the number times 10, right? 135 times 10 puts that 0 at the back. And keep going. This is divisible by 5. 27, yeah. And then this is 3 times 9, and this is 3 times 3. So there's all those. And then the 10 back here is 2 times 5. So there's all the pieces. So let's write that out. So I just broke it all the way down. So the 1350 has 1, 2, 3 3s, a 2. So I put the 2 first, 3 3s, and then 2 5s. So that's the guts of a 1350. It's all the little pieces in a 1350. And then it's got the 4 x's, right? X to the 4th. Oops, that's a funny x there. All right, so now what are we supposed to do? There's nothing in the hook of this number. There's nothing right there in the hook. So what number's really there? An invisible 2, which means this is a square root. It's a 2-for-1 deal at target. 2 3s, get rid of that. 2 3s in, sends 1 3 out. 2 5s in, sends 1 5 out. And they multiply on the outside just like they were on the inside. So that's 15. This is gone, this is gone. 2 x's in sends an x out. 2 more x's in sends another x out. X times x on the outside is x squared. What's left in the root? 2 times 3, in other words, 6 is all that's left in the root. Everything else shipped out. So there's our answer, 15x squared, square root of 6. Okay, so number 17, we have a cube rooter. So that's going to be a 3-for-1 shipper. Let me rewrite it here. So we have the cube root of 40t to the 8th. Okay, 40t to the 8th. Okay, let's break it down. The 40 is 5 times 8. That is 2 times 4, 2 times 2. So there's all the little pieces of a 40. So what do we have? Let me rewrite it. We have the cube root of 5 times 2 times 2 times 2. Right? 2, 2, 2, and 5. And then t to the 8th. So that's 1, 2, 3, 4, 5, 6, 7, 8 t's. Okay, let's ship it out. Now this 3 in the hook here means it's a 3-for-1 shipper. So I circle groups of 3. So 3 2's in, sends 1 2 out, and they're gone. It's like a 3-for-1 deal at target. Last problem we did, this one had nothing in the hook, which really meant 2, problem number 16. So that was a 2-for-1 deal, right? I circled 2 3's and 2 5's and 2 x's and 2 more x's, and they each shipped out one of their type. It was a 2-for-1 deal, 2-for-1, because there's nothing in the hook, which means 2 square root. But now we have 3 in the hook, cube root. It's a 3-for-1 deal. 3 2's in sends 1 2 out. 3 t's in sends 1 t out. Another 3 t's in sends 1 t out. Okay, so what makes it to the outside here? 2t squared, right? 2t. And then what's cube root, right? Keep that 3 in the hook. You got to have that 3 in the hook. What's left on the inside? 5. And tt, so t squared, 5t squared is left on the inside. There's our answer, 2t squared, cube root of 5t squared. Okay. Number 18. So I'm going to rewrite number 18 here, the fresh screen. Cube root of y to the 4th. And cube root of 16y to the 5th. All right, well, the best way is just to lump all this stuff together. Let's just put it all together. Y to the 4th. In fact, let me just write all that out. Y to the 4th is 1, 2, 3, 4 y's. 16 here, I'll break it down over here. 16 is 4 times 4, which is 2, 2, 2, 2. So 1, 2, 3, 4 2's, and then y to the 5th is 1, 2, 3, 4, 5 more y's. So there's all the stuff in the cube root. I should make that bigger. That's all in the cube root. Okay, so now it's a cube root. It's a 3-for-1 deal. So I'll do the numbers first. 3 2's in sends 1 2 out, and they're gone. 3 y's in sends 1 y out. 3 more y's in sends another y out. And 3 more y's in sends another y out. Because we had 9 y's in there already, right? We had y to the 4th and y to the 5th, which meant y to the 9th inside. And then that was 3 groups of 3, right? 1, 2, 3 groups of 3 y's, each sending 1 out. Okay? And then what's left on the inside? Is there anything left in there, inside that root? Just this extra 2, huh? That's all that's left. All the y's came out and all the other 2's. So what's our final answer then? 2y cubed, right? 3 y's. Cube root of 2. Got to keep that 3 in the hook all the way to the end. We never change the number in the hook. 2y cubed, cube root of y. Okay, number 19. What are we going to do here? Well, this is a dividing problem, so we can just divide right in the beginning. Let me just rewrite it here. Square root. There's nothing in the hook, so this is a square root of 15xy cubed over the square root of 5x. Here we go. 5 goes into 15 3 times. X cancels x. Probably it's confusing where I put that 3. I'll just put the 3 right there. So 5 went into 15 3 times. So notice the bottom is gone. See how this is just totally gone? The 5 and the x canceled into the top, divided into the top. 5 went into 15 3 times, and x canceled out x. So the whole root's gone from the bottom. What's left in the top? Just a 3 and y cubed. Because this x is gone, the 15, 5 went into 15 3 times, and then the y cubed. Now, we can't leave it that way. We can simplify that. So we divided first. First we divided, and now we break this down. Y cubed is y. And what are we going to ship out? What's in the hook here? There's an understood 2. There's nothing, which means it's a 2 for one deal. 2 y's in, sends 1 y out, and they're gone. 2 for one deal. Out comes a y. What's left in the root? 3 and the other y. Y, square root of 3y is the answer to number 19. Okay, then so number 20. Let me rewrite it on a fresh paper here. Fresh screen, 20. Cube root of 343. X to the 5th over y to the 3rd. Okay, let's break down that 343 first off. So divide by 3, I think. No, it doesn't divide by 3, does it? Okay, this is a more tricky one. Use your calculator. Just try dividing by different numbers, and what you'll find is it divides by 7. If you divide it by 7, you'll get 49. So just guess around. So 7 times 49, and then 49 is 7 times 7. So 1, 2, 3 7s. Okay, so then this becomes cube root of, that 3's in the hook there, right? Let me stick it in the hook a little bit better. Cube root of, what's the top? 7, 7, 7. That's the 343. That's the guts of the 343. X to the 5th, 1, 2, 3, 4, 5 x's over y to the 3rd, 3 y's. Okay. So now, what is that going to equal? Well, let's do this. Whatever comes out, let's see, 3 7s. Out comes 1 7 on the top, and they're gone, right? So 3 for one deal, 3 in the hook. 3 x's also on the top. Sends an x also out on the top. So we're going to get a 7 and an x on the top. Cube root of what's left inside? Those 2 x's. X squared is left inside. What comes out on the bottom? 3 y's in, sends 1 y out in the bottom. And the bottom is totally, the root is gone. And so here's our answer. How'd I get that again? On the bottom, the 3 y's inside the root sent 1 y outside the root, and so there was no more root on the bottom. Everything came out on the bottom. On the top, the 3 7's in sent 1 7 out, and the 3 x's in sent 1 x out, but 2 other x's were left over inside the root on the top, right there. So there's our answer, 7x cube root of x squared over regular y. So there's the whole practice exam.